inverse functions and then composition of functions. What do you guys remember about inverses? Yes, so for an inverse. And what do you remember about it graphically? I think one of the easiest ways to think about that is let's take like a line y equals 5. What does the graph of the line y equals 5 look like? It's just a horizontal line, right? Okay. If I look at the line y equals x, and I know that's what I'm going to reflect over, so the point on that line would stay. This guy would come over here. This guy would come over here. So what would it become? What is the inverse of y equals 5? X equals 5 is your inverse, okay? But I think that's a very simple one to see graphically what's happening. The next thing you have to do with the inverses, you guys are going to prove that two functions are inverses. It's not proof like what we did with trig proofs. It's just a process you have to follow. And then prove whether or not f of x and g of x are inverses. So I give you f of x is 2x minus 6. G of x is 1/2 x plus 3. You remember this? You guys remember what composition is? Yes, you do. So, to prove it, we are going to do f of g of x, see what that equals, and we're going to do g of f of x. And do you guys remember what they're supposed to equal if they're inverses? No? Yes. They're supposed to equal just x. Okay? Which, just think about it, it's the line you reflected over, that's what they should equal. Okay? So, f of g of x, I plug all of g of x in, so that would be 2 times 1/2 x plus 3, and then minus 6. So, distribute, what's 2 times 1/2? 1, so that's just x plus 2 times 3. 6, okay, that's not supposed to be the hard part. So x plus 6 minus 6, we get just x, yes. But do you guys see the work that I'm showing there? That is what you have to show to prove it. And we do have to do both, okay? So we've done f of g of x, it worked. You also need to do g of f of x. So we're going to do 1/2 times 2x minus 6. Bless you. So when I distribute this time, I get x minus 3 plus 3, which is just x. So, are they inverses? Yes. Yes. F of x and g of x are inverses. Pretty simple. What if they're not inverses? What happens? It won't be x. So you do the first one, f of g of x, and you get like 7x plus 2. Do you need to keep going?
No.
No, you've done enough. enough to show that they are not inverses, okay? Bless you. Man, everybody's just struggling today. You struggle every day. Okay. All right, next up we are going to do some function operations. So the first operation we can do is the sum of functions. That looks like f plus g. Shocking that it looks like f plus g. What that means is you actually take the function f of x and you add to it g of x. Yes, that is very simple. That's fine. What do you think the next operation might be? Yes, we'll say difference. So that's f minus g, which means of x minus g of x. What do you think might come next? Yep, we'll call it product, but absolutely multiplication. F times, you can use a little dot. F of x times g of x. What do you want to do? Oh yeah, Anna. They're just two functions. So like up here, how f of x was 2x minus 6 and g of x was 1/2 x plus 3, it's something like that. Okay. And so like if you're adding the two functions together, you would do 2x minus 6 plus 1/2 x minus or plus 3, and then just simplify. 2x minus 6 plus 1/2 x plus 3. Like you take whatever the function f of x equals and add to it whatever the g of x function is. Okay. We'll do some examples of these too. The biggest piece of these is figuring out the domains. So, after product, what do you think? Dividing. Do you guys know another word for dividing? Quotient. Quotient. Very good. That is a U and then an L. Okay. So that's like f over g, which means f of x over g of x. Guys, of those four, which one do you think probably has the most complicated domain? Quotient. Yeah, you've created a fraction, so that's going to create some sort of issue with your domain. Yes, good times. And there is actually one more.
Cross product.
Cross product? No, it's just the composition. Yeah, sorry to disappoint there. You guys will see it written a couple of ways. You're used to seeing it like this, right? And that actually, we'll put that in there.
There's a big circle.
Yeah, you can do the little open circle in the middle. That does not say fog, okay? That's f of g. Or if you did it the other way, that is not goth, okay? That is g of f. What it means is the function notation you guys are used to, the composition. Okay? All right, let's see the number of my Sounds like some serious whiteout. Oh, yeah, the little like clapper things. Yeah. You guys should just start using those in class when you understand something. You should be clapping. You're walking one day. Would make it more fun. All right, so let's try one. you are given f of x equals negative 4x squared plus 1, g of x equals 1 over x plus 2.
Here we go.
Whew. Okay. So we're going to find a lot of parts with this. The first one we're going to do is f of g of negative 1. You guys are used to seeing it with just an x. It's actually easier with a negative 1. So you don't even know what's happening. I'm giving that, like, this is the question you would get. I'm saying find f of g of negative 1.
So you plug g into f of x, right? And then you do the negative 1.
You can't, or you can, no, it's composition. So, like, it's replacing the x. Or you can plug it into g first, and then that answer plug into f. I think that's the easiest way. So, guys, yes. What this means is f of g of negative 1. Okay? So, it's up to you. There's two ways to do it. You can actually do f of g of x, the composition, and then plug the negative 1 in. Or you can start by plugging the negative 1 into g, and then plugging that answer into f. I think that's easier. So let's just, I'm going to do it that way. So I would start by doing g of negative 1, which would be 1 over negative 1 plus 2. So what does that equal? 1. Positive 1, right? Yeah, sure. All right, so then I take that answer, and now I have to do f of that answer.
Whoa.
Okay. Crazy stuff. So what do we get? Negative 3, yes. So that is the actual answer for f of g of negative 1. It equals negative 3. Okay? Questions on that? We would all be clapping. All right, you guys try this one. You are going to find for me g of f of 2.
Wait, why did you drop?
I didn't do that. That was just like... We're just practicing. So does everybody get to go outside at some point today? Even after school? Like,
I run out of the building.
you run away? Okay. It's so nice out. Yes. Just got really angry. All right, guys, what are you getting for g of f of 2?
Yeah.
Do we have an answer, or are we struggling?
-1 over 13.
It is negative 1 over 13. Anybody struggles with that one? Okay, so first you do f of 2.
Yeah.
So that's going to be negative 4 times 2 squared plus 1. So 2 squared is 4 times negative 4 is negative 16 plus 1 is negative.
Negative 4 plus.
Oh, okay. So
Yeah, I'm kind of slow to take it.
it's a little bit of a struggle today.
Yeah.
Okay, so you're okay with that?
Yeah.
All right. So let's try again. Hopefully you have f of x and g of x written down somewhere. No? I want you to find f of g of x. So, right You can almost see them. F of G. My little circle got a little bigger than it was supposed to. I'll write them for you again. And guys, I would like it simplified as in like one fraction. When you're ready, look up here and see if you got what I got. And if not, ask me questions.
Oh, so you made one
I made a common denominator. Yes. The fours cancel, yes. All right, guys, how are we doing on that? Anybody issues? I see people still writing. Did you get it, Jonathan? That's 1/4. What do you mean? Oh dear. Okay. No. So let's say I have 3 plus 4 over 3 plus 4 plus 5. Do you think that's 1/5? No. And why would the other one be 1/4? Do you get it? Okay. So that's your answer. You would have to be able to factor it out completely and then do to cross it out. So, all right. So we're okay with C. Okay. So now I'm going to ask you find the domain of f of g of x. So domain, when you do composition, the only part that's weird is when you look at your domain. This one that's on the inside, this g of x, you need to start with any restrictions that come from that function. So as I look at my two original functions, if I look at g of x, what can x not equal right away? Like, what are we? Okay. So we know that We got to remember that. Then you actually look at your composition that you already did, and you had this denominator, x squared plus 4x plus 4. We don't want that to equal 0. You multiplied it out, so hopefully you can factor it. What does that factor into? Yeah, it's the same thing. We just squared it. So x cannot equal -2. It was the same as what we started with. It's not always going to be the same. So then your domain is just -∞ to -2, -2 to infinity. Or if you like the other notation, okay, either of those works. Sorry, let me move it up for you. So everything we've been doing with domain, you definitely need to remember that for these. Probably here. Domain, remember, there's just like the two issues. You just look for, is there a fraction, is there an even root? And then go from there, so. Oh, okay, yes, practicing those is always good. Okay, I think I'm on number 3, right? All right, write h of x is a composition of two functions. So I give you h of x equals square root of 3x squared plus 1. So, you need to come up with like an f of x and a g of x so that h of x can equal f of g of x. It sounds complicated, but it's really not that bad. There are a lot of different ways you can do it, some much simpler than others. Anybody have an idea? Yes. That's fun for me, let me tell you. Yes. There's a simple way to do it. Anybody see it? Look.
Is it just f of x is square root of x, and then g of x is 3x squared plus 1?
That is definitely the simple way to do it, yes. Okay.
Oh, yeah.
Makes sense? Because if you plug g, so then we would say h of x is equal to...
X. Not. Oh, no, never mind.
Okay.
Could you just say 1 and that and the function?
What do you mean?
Like 1, like f of x equals 1 and g of x equals square root of 3x squared plus 1.
No, because then there's nowhere to plug in. You could do f of x is x, and g of x is square root of 3x squared plus 1. That's another very simple, cheaty kind of way to do it. But yeah. Let's try one more of those just to make sure you guys got it. 1 over 3x squared plus 5x minus 7. How's your video going? Oh, okay. All right, so what's f of x going to be? 1 over x. And g of x? Okay. Easy. Yes. Okay. We've got a little more to do, guys. I know we're running out of time. We just have like 2 more examples, okay? Alright, we're going to find the inverse. Do you guys remember how we go about finding the inverse of the function? Yep, so step 1 is switch x and y, and then what? Good. Step 2, solve for y. So I've given you a very easy one to begin with. So what would my inverse be? Okay, or you can,
Oh, yeah.
that's totally fine. And guys, technically, if we're talking about the inverse, you should put the little negative one, but I'm not going to be picky about that, okay? If you just solve for y, I'm good with that. Everybody good with a simple line? Okay, so let me make it a little more complicated. Let's make that a 5. Oh dear. All right. Step 1 is still the same. So we would have x equals y plus 3 over 2y minus 5. Okay, then what? Okay. All right, so I can distribute on the left, and I have 2xy minus 5x equals y plus 3. So remind yourself here, what are you solving for? Y. How many y's do I have? 2. Okay. So we clearly can't just subtract 3 and be done with this, okay? You wouldn't have actually solved for y. So what I need to do is get everything with a y on one side, everything without a y on the other side. So I'm going to leave my 2xy, then I'm going to subtract y, equals, I'll have 3, and then plus 5x. Everybody with me on what I did there? Okay. So what can I factor out on the left? Y. 2x minus 1. So, what is my final answer? Yep, just divide. So 3 plus 5x over 2x minus 1. Okay. All right. So just a couple thoughts. You don't have to write any of this down. Do you think every function has an inverse that is a function? No. Okay, good. Give me an example of one that doesn't. Parabola, yes. Because if you start with y equals x squared, the inverse looks like this. Clearly not a function. What is it called if your original and the inverse both are functions? Do you guys remember? 1 to 1. Remember so much from algebra. So, wow, that's home. Yeah, we need a little yoga in our life. 1 to 1. That means the function, so we'll say even the original function. And its inverse. Are both functions. Do you guys remember how to test that graphically? Yes, horizontal line test. So if it passes the horizontal line test and the vertical test, that's a one-to-one function. Okay. Question on anything, guys? All right. You have a whopping 5 minutes to start on your homework.